Today's topic is optical instruments. Here we will study microscope, telescope, and some eye defects. Now let's see how our eye see objects. If we take an object of this much height, we take an object of this much height, which is placed at a distance d. Now, every eye cannot see an object closer than this distance, and which is called this point is called near point. If this point is brought any closer, then what will happen? Suppose the object is placed here. This angle will become steeper and we will not be able to see it. So this is the farthest place. This is, the nearest point we can see easily. But if this point is brought any closer to our eye, we will not be able to see. That is why it is called near point. Okay. If we place an object at near point, an object of height h, the angle subtended there is theta. Okay, like this. This is our eye. This is the object, and it subtends an angle theta. Now, if this angle, this object is brought any closer, in this configuration, the image is formed on retina. This is retina. In case we bring any object closer, the image will be formed not on the retina, but before retina. Okay. Now, so how can we make this object? How can we make this object bigger? Okay. What we do is we take the help of a convex lens. Our object still remain the same of height h. And what we do is we keep it very close to the focal point of this convex lens, close to focal point. This is our U0. And if we see the ray diagram, if we keep our object close to focus, then what we will get, is we'll get an inverted, an erect image, but a virtual image. Okay. It doesn't matter to us whether it is real or virtual, because if you put your eye here, you can still see the image as virtual. Now, if you can see this image is far more enlarged. Okay. Now let's see the treatment of this. If we calculate the magnification, magnification is theta by theta naught, or theta is this angle and theta naught is this angle when we were seeing the object without any lens, with the naked eye. This is also equal to h by u0. u0 is this one, which is the distance of object from the lens, divided by theta, which is h by d. H is this distance and d is the near point. Okay. Now this becomes d by u0. Now what happens if we bring this object close to f, absolute on f? Then what happens? This image that we see will be parallel, absolutely parallel. Yeah. So if we make our u0 as f, then we get image formed at infinity, and that condition is called adjusted for normal viewing. When we see any object at infinity, our eye is most relaxed. And here, the image formed at infinity. Okay. Now, if we apply lens formula, or this implies if we use the convention, since u is on this side of the lens, the rays are going this side, so this will be minus u. V is also on the same side, this becomes this one. Then our this we can call as u0, same as this one, u0. Then what we have is d by u0 is equal to this is because what we have done is we have taken V as, and D is our near point. So this expression means this is adjusted for near point. Okay. Our formula for magnification, same as angular magnification. Which is equal to, we have seen it earlier here also. This is equal to this is the formula when we are not doing any adjustment. This is without any adjustment. So theta by theta naught is equal to d by U0. This is without any adjustment. Now, if we adjust it for near point, then what happens is we can write this as, or we can write our magnification as this is our formula for near point adjustment. What it means is we are assuming that our image is formed at near point. That is why we call near point adjustment. Normally, near point is about 25 centimeters from the eye. Next topic is compound microscope. How does a compound microscope look like? Looks like this. Let's see the construction. We have two lenses. One lens is here. Second lens is here. Our object is here. When the rays from this object goes through this lens, it forms a real image here. Now, what we do is we adjust the placement of this image in such a way that this image is formed very close to the focal point of this lens. So depending upon exactly where this image is formed, we again get two cases. One case is when this image is formed at infinity, or second case is when this image is formed at near point with respect to our eye. These are the two cases. Okay. Now, if this lens through which the object is placed near this lens, and what we do is we view this object through this lens. This is called eyepiece because our eye is close to this. This is called objective because the object is close to this. Now, an object of height h, the distance from lens is u0, and let us say this is the focal point. So this is the focal length of this particular lens, and an image is formed here. So this distance is called v0 for this particular lens. Now let's come to this particular lens. This distance will be u for this lens, right? And this is the focal point of this lens. And this whole distance position from between these two lenses is called the tube length. This is the tube length. We put our eye here to view it. Now this is the height of the object. This is the height of the intermediate image. And this is the height of our final image. Okay. Let this angle which this image makes with the eye is theta dash. So let's see the mathematical treatment. magnifying power, we first calculate the magnifying power, and we know theta naught is equal to h by d. This is our theta naught. This theta naught is the maximum angle that I can see. This is the height of the object. This is our near point. Now theta naught, theta dash will be, theta dash is this particular angle. This angle is what? This height. This is the image actually which is formed. This distance over this distance. This distance is UE. So our theta dash is UE. And our magnification becomes theta dash by theta naught is equal to h dash by UE. Now h dash by h is also we see in this triangle, this over this is equal to this over this distance. Yeah. And we simply denote it as V by U. Our is our magnification. Our magnification is then when there is no adjustment. So this magnification, which was defined here, we bring it here. H dash by h we replace by V by U, and this is as it is. So this is the magnification when there is no adjustment which is done. Now what can be done? If we put our UE at focal point of the eyepiece, meaning thereby if this image is formed exactly at this place, then what will happen? The image will be formed at infinity and these rays will become parallel. Okay. So if we can write it, This is the case when image is formed at infinity, and when we call this condition as adjusted for normal viewing. In this case, the eye is most relaxed. If we apply our lens formula, to eyepiece, eyepiece lens means this particular lens. Then as per convention, what is our V? V is formed in front of the lens, which is against the rays, so V will be negative. What about U? What about image? Image is also formed in front of it, that will also be negative. So our V is negative, and if we multiply by V, the whole thing would become since this is eyepiece, this will be this thing. And our U also was negative because U, the object is in front of the lens, so this becomes positive, and this becomes U is for UE. This implies that our V plus UE is equal to this is our one relationship. Okay. So in this case, our magnification becomes we take this as the original formula, where magnification is V by U into D by UE. Now, here if we replace V by D, meaning thereby if our image is formed at near point, then this relationship, this is also equal to this is when we are adjusted for near point. Now, using this formula, and we will bring it back here, magnification is U by E, D by UE, and we substitute D by UE from here. This is our formula for magnification for near point adjustment. So we have seen our magnification for normal viewing and as well as for near point adjustment. We can also find magnification in terms of tube length. You know, V by U is equal to what is V? We have seen V of this eyepiece is very close to its focal point. So we can approximate V as let's do apply lens formula to objective. V is formed for an objective. V is formed here on the other side, so it is positive. U is on this side. The ray direction is this, and our distance for U is this, so U will be negative. So our V is positive, U will be negative, F is again positive. So this becomes now if we multiply both of them with both sides with V, what we get is or or now the value of V by FO is far greater than 1. So we ignore this one, and what we get is now this V, this image, first image of the objective is formed very close to eyepiece. So we can say effectively this is nothing but tube length. So this becomes our relationship between V0 by L by FO. So wherever we have V by U, we can replace it with this. And if we go back to our previous equations, when there is no adjustment done, V by U, U by E. E by D by UE, and this we can now write as V by U. We can replace here. This is the case, then now another case was for near point adjustment. For near point, what we have is, instead of D by FE, we have 1 plus D by FE. This becomes our this is for near point adjustment.